Well, yesterday we're done with log 17. Have you got any questions? I think I put the assignment in place. Okay, let me double check. Okay, do you have any questions? No question, yes. All right. If you have any questions, don't hesitate to ask. You can ask anytime. We will continue our topics. Okay, so we have done log 17. Okay, finding domain. So let's look at log 18a. Let's look at log 18a. Okay, this is a set of exercise that's solving inequality. Okay, solve inequality. Okay, we actually did an example the other day. How do we solve these inequalities? Right, how do we solve these inequalities? The general ideas are still similar, but at some places we can use the properties of the specific function, such as increasing, decreasing. Okay, take the first one, for example. The first one says ln x is less than 0. Okay, and of course we do all of these in the domain. Okay, so we need to be aware of domain. So ln x, we want ln x to be greater, to be less than 0. Okay, because ln x is an increasing function. It's an increasing function. So as a result, there are different ways to do this. I'm going to explain to you the way we do it algebraically and the way we would do it on the graph. Okay, which we have shown this before, with other functions such as sine, quadratic, and some of the functions we have encountered, right? Exponential, and so on and so forth. So let's look at the first method, right? The first method. Of course, first of all, we need to decide the domain, right? Domain. So everything is operated in the domain of the specific function. And what is the domain here? So we're talking about the domain of ln x, right? The domain of ln x is, anybody would like to take up that question? What is a domain? Hello, anybody want to say something? What is the domain of ln x? Let me look at the chat. X is larger than 0. X is larger than 0. Excellent. That's right. Okay. The domain for ln x must be x must be greater than 0. Excellent. I like the fact that you guys start using the inequality, right? The inequalities. Very good. All right. And the other thing is I like to explain is that ln x as an increasing function, right? So I'm going to put it this as a think out aloud. Okay, think out loud. ln x as a increasing function, right? ln x is an increasing function. What does it mean? ln x is an increasing function over in its domain, in the entire domain. Okay, in its domain. What it means is that as a function, okay, as a function. It gives you, the input is x, and we want the output to be less than zero. Of course, we want the output to be less than zero, right? Less than zero. Output less than zero. And 0 is ln1, right? 0 is equal to ln1. So when we say if ln x is less than 0, that is the same as saying if ln x is less than ln1, right? So the output, so these are the output, right? These are the output. ln x is one output. ln1 is one output. For increasing function, when the output one is less than the other, and their input is also x, is less than the other, okay, in the same order, okay? Because the definition, okay, I want to revisit the definition of an increasing function, okay? I know this answer comes very quickly, but I do want to explain this very thoroughly, okay? The definition of an increasing function is, okay, f of x1, x sub 1 is less than f of x sub 2, okay, whenever, okay, x sub 1 is less than x sub 2. What it means, okay, what it means, okay, what it means is this. We have x goes through this function, okay, which is f of x, okay, this is the general definition. So it comes out f of x, okay. An increasing function is saying, if x1, x sub 1 is less than x sub 2. Okay, on the other side, on the output side, f of x1 is also less than f of x2. So that's what it means. Okay, that's what it means. So we want to see this from that perspective. Do you guys follow me? And this is only true for increasing function. For example, for decreasing function, it will be reversed. Okay, I'm going to give you an example of a decreasing function. So you cannot always just drop it, cross out. Sometimes I see students come to the class, they just cross out the ln. No, that's not how it works. That's not the narrative. The narrative is because ln x is an increasing function. And because we know the output is in this relationship, and therefore we know the input is also in the same relationship. Are you guys with me? Are you guys with me? This is very important to understand. This is very important to understand. Okay, so knowing that ln x is the output for x, ln 1 is the output for 1. Because ln x is less than ln 1, therefore we knew that x should be less than 1. Okay, I will show you the version of you normally will work it out, okay? But also we have to think about the domain, right? So ultimately the answer is that x has to be in the domain. So that will be the answer. That would be the answer. But I put all of these together, right? I put all of these together. So let's see how we show the work. Okay, so I'm going to show you how to show the work. Okay, so treat these part as just something like, on the scratch paper or think out loud, right? But when you actually show work, you don't need to show so much. You don't need to show so much, okay? So show work. Okay, so when we solve that, we're gonna address, right? So when we solve, right? And then solving in the domain, and then you would just say, okay, and x is less than 1. Okay, so the solution combine with the solution, right? And we will get x between 0 and 1. That's it. You really just need to show this much work. You got it? So if this is true, then this is true. And that's the solution, combined with the domain. So far, so good. But all the thoughts went in there. All the thoughts went in there. So I'm going to put it at the end of the question because I have some other notes I want to show you. Cut it. Okay. So show work. This is a little redundant, right? So the solution is just this little part. That's it. Okay. On the notes, I'll put it on the notes. On the think out loud part. Okay, on the think out loud part. So this is a note. Okay, this is entirely on the scratch paper, and you guys, I spend time to explain it to you because I want you to really understand this. Okay, so this piece is called note number 1. Note number 2. Okay, if the function is not an increasing function, we cannot do what was done in note 1. Okay, we cannot do that. Examples. Okay, for example, if sine of x is less than pi over 2, root 2 over 2, sorry, root 2 over 2. Okay, if sine of x is less than root 2 over 2. Okay, and of course we know that root 2 over 2 equals to sine of pi over 4. Can we say, oh, x is less than pi over 4? Can we do that? Can we do that? And of course, I told you we cannot. Absolutely not. Because sine is not an increasing function. Sine is not an increasing function. So you understand, we can drop, we can go from output and go draw conclusions about input. It's because it's the increasing function in the ln x case. In exponential function case, that's okay too. But it depends on what exponential function. Some exponential function is increasing. So only for increasing function, you can do that. If it's for decreasing function, you have to reverse the relationship, okay? So we cannot, okay, cannot do. Okay, so cannot do. Then what will be the solution? What is the solution? Right, what is the solution? We're gonna put this question on the side. Okay, we're gonna come back to it. Okay, because this solution is a little bit more complicated. We have to look at the graph. Have a look at the graph. Okay, note number 3. Note number 3. If the function is a decreasing function, then you have to do the opposite. Okay, we have to do the opposite, right? So in note number 3, so do we have an example of a decreasing function? Of course we do. Of course we do, right? So that concept of increasing function, decreasing function. Okay, so let's see what do we know about decreasing function? The definition about a decreasing function. Okay, so we're gonna take the whole thing, and I'm gonna make some changes. Okay, it's a decreasing function, right? Reversed. Reversed. Okay, that's the definition of decreasing function. Do we have an example to it? Yeah, we do. Right? You can see if the function value, if it is a decreasing function, and we know the output has this relationship, and the relationship in the input is reversed. Okay, for example, right, the function 1 over x is a decreasing function. You're actually going to use this function quite a lot in calculus classes. Okay, sometimes you use a subset of this function. Sometimes you use, you know, in calculus classes. I mean, not just one calculus class, multiple calculus classes. Okay, so you suppose, you know, give you an example, right? This is a decreasing function. You can see that from the graph. We can see that from the graph, right? This keeps going down. There are 2 pieces, right? Do you guys still remember the curve of this graph, this function? It's a decreasing function, isn't it? So how does the graph look like? That's how the graph look like. Decreasing. Okay, as x is getting larger, y is y. But there are 2 pieces. There are 2 pieces, right? This piece is decreasing and this piece is decreasing. Okay, so this function is decreasing. Say we talk about this piece, the positive side, positive piece. Let's see. I'm going to just move it. Okay. This is decreasing function. This is decreasing function, but on one piece. If you 2 pieces combined, is neither. It's 2 pieces combined is neither. So only for this piece, right? So we choose the positive piece. Since we choose the positive piece, so I'm gonna make some changes. Just that piece. It's a decreasing function. It's a decreasing function. On this decreasing function, we can do that. Okay, so there are a lot of interesting facts. I want you guys to think about it. I'm going to give you an introduction. Okay, so let's put it just this piece of function. Okay, so I'm using this function, and be aware, and the function I chosen is not a 1 over x alone. It's 1 over x when x is positive. Okay, so it's a half of the function. This is a decreasing function. Okay, well, to give some examples of decreasing function, you can see that, you see 2 is less than 3, right? 2 is less than 3, but 1/2 is larger than 1/3, right? So whenever, okay, so whenever x1 is less than x2, it could be any two such numbers, okay, larger than 0, okay, 1 over x1 is going to be larger than 1 over x sub 2. So it is indeed an increasing function. So if you know the output is this relationship, the input will be the reverse relationship. Okay, so for decreasing function, you can see we cannot do what can be done for increasing function. Is that clear, everybody? Okay, so understand note 1, note 2, and note 3. Now, let's look at the other method of solving ln x less than 0. Okay, so this is method 1. I want to show you method 2, and then we're going to work on the sine function. Okay, how do we solve that? Okay, method 2. Okay, how do we solve this inequality from the graph? Sometime when you are in a calculus class setting, you may want to go use some graph. And in some other cases, you have to use a graph. You have to use a graph. Okay, so now method 2. So in this case, I'm going to use the graph. Okay, ln x. Okay, so I'm going to graph ln x. That's ln x. We're pretty familiar with. Okay, making some adjustment to the picture. And this side is just there. That's the picture. There we go. Okay, so what we want ln x less than 0. That's what we wanted. We want the output to be less than 0. So where do we find output less than 0? And then you have to understand what is the output, right? What is the output? This is output, but that's positive. This is output for that input, output, input, output. This is a negative output. These are negative output, right? So you look at the curve, right? These are positive output. Okay, so if you mark it, these are positive curve piece and these are negative curve piece, and we want it to be negative. We want the output to be negative. Is that clear? Okay, so let me make the picture cleaner. So this piece is the output less than greater than 0, and this piece is output less than 0. And over here, it should be a circle. Right, it's a circle. So it's obvious the solution is going to be between what? The input, we're looking for values for input, so be between 0 to 1. Isn't that obvious? So the graph tells us very, very clearly, very, very loudly. Okay, so that solution unmistakably solution obviously is 0 less than x less than 1. Right? Has to be, is it? So the picture tells us, so we have to know how to read the picture. How do we read the picture? From the beginning of the semester, we've been talking about function as a rule. We have input, we have output. Sometimes we give an input, we're looking for output. Sometimes we give an output and we're looking for input. In this case, we're given the output. We want the output to be negative. Okay, we want the output to be negative. So you need to know from the graph, where do I find negative? Isn't this similar to what we did with quadratic? Absolutely, quadratic, right? Remember that quadratic inequality we solved, right? So for example, x squared, I think it should be this example, right? Quadratic, right? We did this in everything quadratic, right? Quadratic. So the view. Sorry, I'm gonna make it just a little bit nicer. Right? It doesn't have to be perfect, really. It's already it's already nice as we can see, right? So if you look at this function, how would you, if you would say, hey, I want to be less than 0, right? We want it to be less than 0. There you go. So this is the output is a given. The output, we want the output to be negative. So where do you find negative output? Here. Positive output. Positive output. Got it? You can see graph can be so powerful in a lot of situations. Okay, in a lot of situations, when we run out of algebraic, or we can combine algebra with geometry, with analytical geometry. Okay, it will often give us a great insight, because after all, we're just dealing with input output, right? We're dealing with input output. So now let's look at that question we posed, right? That question we posed. So this serves as some kind of review of trigonometry, right? Let's serve this. Let's look at this as some kind of review of trigonometry. How do we solve this inequality? Right. So I'm going to expand on that. How do we solve that inequality? We know what we cannot do, right? But what do we do? We know what we cannot do, but what do we do? Anybody? The same idea. Same idea. We draw the curve. We have the curve. Right? What is this question about? We know the output. We know the output. Okay. So you can see this, say, I'm going to give you this, a lot of these pieces of curve. There's a lot of it. Okay, so that's the curve. That's the curve of sine. Okay, and we want the value to be less than pi over 4. I'm sorry, less than sine pi over 4. Or just a square root over 2. Okay, just root 2 over 2. It doesn't matter how you write it, right? But there's all these connections. We know what we cannot do. So how do you solve this inequality by graph? Right? In this case, because they didn't give us a specific interval, So we're gonna look for solutions in the entire domain, and the function, right? The function, of course, is sine. And it produces output. That output is sine x. Okay, the output is sine x. So this curve is sine x. So what's the input? The input is horizontal. The output is vertical. The output is given. We want the output to be less than. We want output to be less than root 2 over 2. And how do we identify that, right? So what we do is that we're going to draw this output square root over 2, so square root of 2 over 2, okay, broken line. So what are the pieces that will make a sine of x less than square root over 2? So where do we find such points? You look at that piece, right? This piece is less than root 2 over 2 because that's the output, right? So all these pieces, and they're related, okay? What piece should be out, because that's above. This line is the level of root 2 over 2. And everything above is not what we want. Everything below is what we want. So these are the pieces that give you the output of less than root 2 over 2. You guys see that? Do you guys get it? And these pieces out. So these are the points that you have to identify, right? You need to identify this point and that input. You need to identify that point and that point. Therefore, so your solution is going to be in pieces. So this piece and their related input will be found. Do you guys follow me? And this piece should be out. And this piece, so you can see it's periodic. Okay, let's try to identify some pieces here, right? Some pieces here. Now, we need to identify this point, and we need to identify that point. That point. How many points do we have? Infinite. Because we're going to go in both directions indefinitely forever. Right? So this is the ultimate, question, how to solve an inequality using graph. It is not increasing, it's not decreasing either. You cannot just cross out the function, right? So what you do, you have to look at the graph. If we can identify these points, and then we'll be able to identify the interval, right? So what is this point? This point obviously is pi over 4, comma, root 2 over 2. Okay, can we mark that point? I'm gonna start marking that point, okay? This point okay, is pi over 4 root 2 over 2. But it has to be a circle because we want to be less than, right? It has to be a circle. How about this point?
Three pi over 4.
Very good. 3 pi over 4. Okay, you can use a unit circle on the side, okay? You can use unit circle on the side. 3 pi over 4. And root 2 over 2. Input, output. As I said, if you figure out everything about in the relationship between input and output for that function, you're set. You're set. But yet we're still exploring that relationship. We're still exploring that relationship, right? So now, so this is one period. And how about this point?
5 pi over 4.
5 pi over 4? Are you sure? We have gone through a period. It'll be pi over 4 plus a 2 pi.
Yeah.
Right? So plus a 2 pi. How do we get this point?
3 pi over 4.
Plus 2 pi. Right? Right? Okay. So let's look at this point. Okay. So this point, okay, mark this point. That is pi over 4 because we want to identify a pattern. That's pi over 4 plus a 2 pi. I hope this exercise will open your mind about the power of a function and its graph. Okay, how about this point? That's a 3 pi over 4 plus what? Plus 2 pi. So you can imagine this process will keep going forever, right? In the other direction, what will happen? What is this point?
Negative
And what
pi
is
over
this
4.
point? And this point would be pi over 4 minus 2 pi, right? So this point is going to be pi over 2, pi over 4. Oh, sorry. Oh. I apologize. What did I do? Okay, there. Okay, so this point is pi over 4 minus 2 pi, comma, root 2 over 2. And this point is 3 pi over 4 minus 2 pi, comma. Does everybody follow me? Isn't that interesting? Very interesting, right? So now we have found the pattern. So by identifying these 2 points, we know that all the other points is going to be plus minus what? 2k pi, 2k pi. And now we're going to identify the solutions. So where do we find the solutions? Where do we find the solutions? We have a solution here. Oops. We have lots of solutions, okay? So this piece we checked, right? This piece is the solutions. Okay, with circles. Okay, now the next piece. Where do we get the solutions? That piece is solutions, because all of those signs, all of these inputs we will have the output less than √2/2. Some of them are even negative. Do you guys follow me? Do you follow me? And you can keep going. Keep going. This piece over here. And that piece over there. Lots of solutions. A lot of solutions. So how do we write them down algebraically? How do we write them down algebraically? How do we write them down algebraically? We can describe, for example, we can describe this interval, right? Can we describe this interval? This interval is 3π/4 to what? To π/4 plus 2π. So this interval right here. Okay, so this interval, right? Okay, is 3π/4 comma, I'm sorry, it's not a bracket, it should be parentheses. Okay, it should be parentheses, my bad. Okay, 3π/4 to what? To 4π/4 plus 2π. π/4 plus 2π. Okay, just leave it like that. Okay, and keep going. And how about this interval? This interval. That interval, okay, is 3π/4 minus 2π minus 2π, right, comma, π/4. Among these, we're going to identify some patterns. So we have identified 2 intervals. Have we? Do you guys understand what I'm talking about? Right? So what do we end up with? So you keep going, right? We keep going. So this is going to be, there's going to be another 2 pieces, and there'll be more pieces. And then we start to identify patterns. Okay. So this will be probably from what? 2k pi, right? And the π/4, we have to plus something, right? I'm going to leave this for you, but I leave this for you. I want you guys to think about it. Okay. Don't worry. I'm not going to give this kind of question on the exam or on any exam. I just want you to think about it. I want you to think about it. Please. Okay. Think about it. If you want, okay, if you want one day, if we have time, we'll come back to this question and see how we formulate the answer, because there's so many intervals as the answer. There's so many intervals as the answer. And I don't want to take up so much time in class. And I want you guys to let this sink through your mind and think about it. Only if you're interested in, okay? Only if you're interested in, okay? And I promise, if you want to discuss this more, we'll come back to it, okay? We'll come back to it. But right now, do you understand how I formulate the solution? Okay, and there are different ways to formulate the solution, so I want you guys to think about it. Okay, this is a very important method. I feel is not addressed enough, especially in these days and age. Okay, graphing is easily available. It's at your fingertips. How do I identify solutions? Right? After all, we just work with input output. We just need to formulate some algebraic solutions. So that's the hard part. Okay, so what I leave off right now, I want you to think about it, and I promise, if you want, we will come back to it. Okay, so just to give you a glimpse of how, we can resort to the graph and give us some enlightenment. Okay, give us some enlightenment. So without further ado, I'm going to put this away. Okay. And I promise, okay, we can come back to it if you wish. Okay. So this will not be on the exams. Okay, will not be on the exams. So don't worry about that part. Okay. Don't worry about that part. Okay. All right. So that's question number 1. We just did question number 1 in 18A. Okay. So we addressed the importance of increasing function, right? Importance of increasing function. So let's look at this is 18A, right? How about number 2? How about number 2? Number 2, we have e to the power x is larger than 5. E to the power x larger than -5. E to the power x is an increasing function. Okay, so here, you know what? I highly recommend we add something here. Okay. On the first question, okay. ln x is an increasing function. You don't have to say more. You just mention this. Okay. In the first method of the first question, I put a note here just to mention it's an increasing function. Okay. All right. Got it? So you want to put that note next to your note. So we may refer to it later, right? E to the power x is an increasing function as well. We know the graph. We know the graph, right? Now, and then what should you do? We can take logarithm, we can take natural logarithm on both sides, and that's the normal procedure. And natural logarithm is also an increasing function. So as a result, x is greater than ln 5. Domain, do we need to worry about domain? Domain of e to the power x is all real numbers. So that's the solution. You see that? But you must understand what you're doing, which is you're doing with increasing function. For example, even though e to the power x is an increasing function, how about e to the power negative x? this is the function you're also going to encounter in your calculus classes. Okay, e to the power x is an increasing function. Okay, and you can put this, here, just to remind. Okay, then this question is already done. Okay, this question number 2 is done. Okay, so question number 2 is done. But e to the power negative x is not an increasing function. This is a decreasing function. You want to see the graph? This is the graph. It's a decreasing function. You see, e to the power x is e to the power negative x is a decreasing function. Isn't that interesting? Right? Okay. So be very careful. Be very careful. Even for exponential, some are increasing, some are decreasing. Okay, some are increasing and some are decreasing. Okay, so take, some of these properties, you're gonna use them. You're gonna use them. Okay, so that's the first method, algebraic method. Algebraic method. How about the method of graph? The graph method. E to the power x, right? The graph method. If we graphed it, this is the function, right? What does it mean? What does it mean? Right? What does it mean we want to e to the power x is larger than 5? The output is given, right? The output is given. What is 5? Well, we want to be larger than 5, right? We want to be larger than 5. There you go. This piece is larger than 5. And this piece less than 5, e to the power x. Do you guys see that, right? The output, these are the output. Output is vertical, less than 5, greater than 5. Follow me? And this level is y equals to 5. So above, so where do you find the solution? So this piece make it, and this other piece doesn't make it. Same idea. Do you see the same idea as we did sine? Yes? Same idea. And you just have to find the point that separates them, right? You have to find the point that separates them. So what is that point that separates it? This point, sorry. This point. What is this point that separates? What is this point that separates them? What is this point that separates them? The input is ln 5. The output is 5. Okay, and of course we're looking for input. Therefore, input must be greater than ln 5. Do you guys see that? Do you have that visual? I want you to have that visual. Got it? Yeah? Are we good? So understanding the graph, understanding input output, right? At the beginning of the semester, we said this semester is entirely about function. It's entirely about input output. Sometimes input is given, we're looking for output. Sometimes output is given, we're looking for input. Okay? Is it still true? Is it still true? Yeah, it's still true, isn't it? And using the graph sometimes is used as a point of reference to check. Okay, it's a very powerful tool to check if you get the answer correctly. So you not only need to check your algebraic, you also need to check your graph. Does that make sense in terms of input output? Okay, so without further ado, let's keep going. Let's keep going. All right, are we good? Because I'm about to erase all of these. Okay, so I'm going to mark that point for your reference. Okay, I'm going to mark that point ln 5, comma 5. A little red dot, and I make a circle, right? So that's the point. That's the point. And this piece above is what we want. This piece below does not satisfy e to the power x larger than 5. So this piece is the answer, and that piece is not. And we're going to give the input to it because it gives the answer to the input. So x is larger than ln 5. Okay. So once sometime when we put it in the picture setting, actually a lot of things is super clear. It's super clear. All right. Let's do you guys want to try some? Some of these questions in 18A, they are from your calculus textbook. They're from your calculus textbook. Okay, number 3 is one of them. Number 3 is one of them. Okay, we're solving this inequality. 1 less than e to the power of 3x minus 1 less than 2. How do we solve that? It gets a little bit more complicated, right? You can use a graph method, you can use algebraic method. If you use algebraic method, we're using, the increasing function, right? Increasing function. There are a couple of ways you can manipulate this algebraically, right? For example, 1 is e to the power 0, isn't it? I'm sorry, e to the power 0, right? How about 2? 2 is e to the power of ln 2, right? Yes? E is an increasing function. Therefore, we will have 0 less than 3x minus 1 and less than ln 2. Okay, so here I'm going to put the note e to the power x is an increasing function. And then we're almost done. We're almost done. Okay, adding 1 to each side. So 1 is less than 3x, less than ln 1 plus ln 2. Okay, divide each side by 3. So 1/3 less than x less than 1/3 of 1 plus ln 2. Okay. And graphic-wise, you can graph this e to the power 3x minus 1, and you want to be between line number 1 and line number 2. Okay, so if you have a graphing tool, okay, I'm going to explain this. So e to the power 3x minus 1. Of course, this picture is a little bit more complicated, right? Domain is still all real numbers. And the picture is about x. The range is no problem, right? And if you want to look at the picture, right? So let me put it -3 here. Let's do 3. So maybe 10. Okay. Let me stretch it just a little bit more. Okay. So -2. Stretching and make it. There's some adjustment needed so you can see the picture well, right? What does it mean between 1 and 2? Right? What does it mean between 1 and 2? Does everybody follow me? Yeah? Does everybody follow me? We want this to be between 1 and 2. Do you think you have an interpretation? What does it mean? 1 broken line. 2 broken line. We want that piece in between. We want that piece in between. Okay, so let me just adjust the scale a bit more. Okay, so 3, say for example. Okay, we want that piece in between. Okay, so the output is between 1 and 2. Do you guys follow me? We want the output to be between 1 and 2. And we want for those output, we want to find the input such that the output is between 1 and 2. Make sense? Does that make sense, you guys? It's all about input output. It's all about input output. Right? So you need to identify this point. We need to identify this point. Okay, so we need to identify this point. And we have found it's 1/3, right? 1/3 comma 1, right? And the other point is 1/3 1 plus natural log 2 comma 2. Okay, that's the input here. So the input, let me make this just a little bit wider, okay, because it's a little bit too hard to draw. Come on. Okay, so we're going to identify these 2 points. Okay, there's a 1 point here, 1 point there. Can you guys mark these 2 points for me? And between these 2 numbers, the input is what we're looking for. The input is what we're looking for. Just this much. You follow me? Do you guys follow me? Okay, do you guys follow me? Yeah, do you follow me? Do you see that geometry? Could you guys say something? Are you guys with me? This is too much? This is called analytical geometry. Okay, this is called analytical geometry. A lot of our students need help in this area. I have some discussions with a guy who teach in a 4-year school. It's the same issue. They have the same issue. Okay, You guys follow me? Here, this point, what is this point? That point, that point is 1/3, comma 1. This point, okay, this point is 1/3, 1 plus ln 2, comma 2. And we want the input in between, and that's what it is. And the output is between what? Between 1 and 2. Does that make sense? It gets a little bit more complicated, right? Doesn't it? It doesn't get a little bit more complicated, but it doesn't move far away from the essentials, right? It doesn't move far away from the essentials. This inequality means we want the output of this function between 1 and 2. So this is 1, right? This is 1 and this is 2. The vertical between 1 and 2. And then we're looking for the horizontal. Okay, so let me put the points in place. Oh, hold on. Okay, so let me put the points in place. Okay, so I'm adding the point to 2 points. 1/3, comma 1. That's a point. Circle. Another point. Okay, 1/3. 1 plus ln 2, comma 2. That's another point. You can see they're exactly where I just drew. Right here. These are the 2 points, right? And these are the axes. So this piece is about the input right here. Did I make myself clear? Did I make myself clear? Are you guys there? Are you there?
Yes.
You got it?
Yeah.
Good, good, okay. So when, in a lot of situation, of course, there are a lot of situation you can just do it by algebraic manipulation. But in some other situations, sometimes we may be out of wit. Think of graph, think of graph. So understanding the meaning of graph becomes essential, right? But if we understand the meaning of the graph, we can always maybe find some, have some ideas as to how to tackle the question at hand. But anyway, without further ado, let's move forward. Okay. And in the following questions, we're not going to spending so much time here, okay, because I'm giving you all these different perspectives, right? I'm giving you all these different perspectives. All right, so number 4, number 5, number 6, may I leave them for you? How about you guys give it a try? 4, 5, 6, okay? Pick one, pick 1, pick 2, pick 3, okay? Pick questions from 4, 5, 6. Okay, just here, you after class, you're gonna have to do them all over. From 4, 5, 6, because before we attack say 7 and 8. Your turn. 4, 5, 6. How would you deal with them? How would you do them? If you want to submit your work, feel free to do that. Okay, all works, all submitted work is welcome. Okay, it doesn't matter. Don't worry about repeats. We can handle it. Have I got some submissions? Yeah. Great. My internet is a little slow. Oh, wait. I opened 2 Canvas windows. Let me close one. Sorry about that. Okay. This one. Okay, got it. My internet is kind of slow. In case that in case we get interrupted, we should come back. We'll come right back. Okay. So I got it. We got that. Bailey's work. Thank you for doing that. Okay. Does everybody see the submission? This is Bailey's work. Thank you for your submission, Bailey. Okay. So now we're solving this inequality. He subtracted 1 on both sides, and then he divided by on both sides. Okay. Of a negative half. And we have another submission. I'll get to it. Okay. Thank you. Subtract 1. Bailey, after you subtract 1, the right-hand side will have 2 only, right? Right? So this will be this will be 2 because it subtracted 1, right? So that's not a terribly big mistake, okay? Just a minor mistake, okay? So that's going to be 2. And then he divided both sides by -2, and then he switched the direction of inequality sign. That's very, very good, okay? Very good step. Okay, divide both sides by -2. It was less than, now become greater than, and of course, because this was 2, so this piece really is going to be just this piece, it should be just a -1, right? Should be just be -1. So we got ln x larger than -1. So what does x equal to? He also showed the graph. He also showed the graph. I really like that. Okay. He also showed the graph. So so he used the definition. Okay, ln x is the increasing function, e is the increasing function. Therefore, x is going to be larger than e to the power of a -1, right? E to the power of -1. So he also demonstrated, right? This piece of curve. So he obviously graphed this 1 minus 2 ln x from a graphing calculator, right? Yeah, you can certainly use your graphing calculator. And then you identify that point, and so it's less than 3. Any questions? So besides this minor mistake, he's good. Okay, very good job. Now, so let's look at the other submission. Okay, so let's look at the other submission. Mikhail, thank you, Mikhail, for submitting. We got Bailey's, we got, I heard another sound. Did someone else submit it as well? Okay, Mikhail's submission. So he did number 4. Let me download it. Oh, I'm sorry. This, okay, there. I found the download button. There we go. New share. Okay. All right. So this is what Mikhail did. Subtract 1 on both sides, and so he corrected that mistake. Larger than -1, so x is larger than 1/e. Excellent. Very good job, you guys. Very good job. Okay. Wonderful. You got it. You got it. So we're gonna go back to our original screen. Okay, so 4, 5, 6. You guys nailed it, right? You guys nailed it. So let's move forward. There are 2 remaining questions, number 7 and number 8. Okay, so let's do number 7 first. Doesn't number 7 look familiar? Doesn't number 7 look familiar? When did we see it? Log 15, right? Log 15. So we know the differences, don't we? We know the differences. We understand the differences. So we're gonna move everything to one side. Okay, we're gonna move everything to one side. So we're gonna have ln x squared subtracting ln x squared larger than or equal to 0. Okay, because I move everything to the right-hand side. And this piece is equal to using power rule, it's 2 times. And by the way, what is a domain? Remember, we operate everything in domain, right? Always be aware of it. Always be aware of it. In your calculus classes, your teacher may not talk about domain every day, but it's always in the background. You always need to be aware, okay, that's a domain, we're operating in the domain. So sometimes you may get a number that's may not be in the domain. Okay, or maybe on the border of the domain. Okay, maybe on the border of domain. So you need always be aware what is a domain on the border, especially when you get to chapter 4 in calculus 1, right? You need to identify those critical points and so on and so forth. So you need to be aware of domain even more acutely. Okay, all right. So this inequality, and obviously we use the same way we handle this question, right? So that we introduce a intermediate variable. So this turned to be a u, and this is 2u, right? And then can we do u squared larger than equals to 2u? And cross out the u? Can we do that?
No.
I'm so happy to hear that. Absolutely not. So please don't do that. That would be a terrible mistake. Okay, we pointed out similar mistake in the equation setting, in inequality setting. Please don't do that. Please do not do that. Okay, okay, please don't do that. Okay. Okay, so we pointed out that mistake. Okay, so don't do it. Don't do it. Factor. Do we know how to solve this inequality? This is a quadratic. This is a quadratic, right? We have so many means to solve the inequality. Can you guys quickly solve this inequality for me? So when we ask you quickly, when I ask you quickly, what will make that quickly happen? The graph. You see, the graph is very handy. The graph is very, very handy. Okay. So you quickly identify, because it's very easy to identify. It's very easy to identify, right? So this is the curve, and we want to be greater than or equal to 0, and the x-intercepts are very obvious. So you're gonna have these points in place, and these are going to be dot. Okay, so which part of the curve will be the solution? We want to be positive or 0. So here, here, out. Right? So where do we get the solution? The solution would be solution for u, right? Solution for u. So u less than or equal to 0, or u greater than or equals to 2. Right? And then we're not done yet. We're not done yet. Okay, we're not done yet, right? So remember, u is from here, right? U from there. So we have two cases. We have two cases, right? So for u, so you say when u is less than or equals to 0, then this guy is less than or equal to 0, right? And 0 is ln1. Therefore, x is what? X is less than or equals to 1. And it has to be considered, we have to consider the domain there. So that's one piece of solution. Another piece, when u is greater than or equals to 2. Ln x is greater than or equals to 2. And 2 is equals to what? It is like ln e squared. It's an increasing function, therefore x is larger than or equals to e squared. Okay, so solution, final solution. Summary of solutions. Right? This piece. Or that piece. Okay. Isn't that interesting? Okay, multiple steps. Last but not least, that's, I think for the remaining 2 minutes, we can do number 8. Number 8. Okay, we have an x squared e to the power x. Do you guys want to try it? Do you want to try it? I don't want to deprive you. Maybe we'll complete this tomorrow. If you want to try it, go ahead, try it. Did I leave out anybody? Because I think I heard that there's 3 submission or 2 submission. Okay, 2 submissions. Did I leave anybody out who submitted last time? No. Okay. All right. You guys want to try some more? Anybody want to submit? Submit your work. Do you want to try it at home? Well, you are already at home. Do you want to try it after class and come back tomorrow? Or you want the answer now? Tell me. I can go either way. But I do want to give you the time and space to think about it because I know you can do it. I know you can do it at this point. You may need more time. Maybe you want to do that?
Maybe you can like give us the first couple steps and then we could try the rest at home.
I will give you one word as a hint. Okay. Factor. Okay, how about that? One word, factor as a hint. And then you go from there. Think about all the things you have learned about those factors. Would that be enough? I'll catch you up tomorrow. You like this better? And of course, if you can hardly wait, you can come straight into my office hours after this. Okay. All right, guys, I will see you guys tomorrow. Okay. Have a great day. Very good job. I'm very impressed. Okay, I'm very impressed. You guys, dedication. I'll see you guys tomorrow. Okay. If you like, you come to my office hours. And have a great day.